So this is going to be for J. This is P arrow Q is entailed by and entails P double arrow Q or Q. So there's a few different ways that you could try to do this one. This also might be one where guilty knowledge is going to be useful though. So I actually would recommend using guilty knowledge. What is guilty knowledge? It's when you know that you can make some type of equivalency change later on, and you just say, hey, what would happen if I want to do that? So this, for example, is the same as this. So we would know to assume P double arrow Q to get to arrow Q instead. So let's start that. I think I can do this in 8 lines, I think. So yeah, let's assume this for the sake of conditional proof. Write down our main given assumption. Then we're going to assume not P double arrow Q. Assume it for the sake of conditional proof in order to reach Q. Then we're going to use the definition of a biconditional. You can use definition of a biconditional even when the main operator is a negation. So we can say it's not the case that we have P arrow Q and P or Q arrow P. And then I'm going to do more, and then I'm going to use, actually I'm going to use SI 34. So when we look at SI 34, 34.1, this is called a conjunctive syllogism. It says that if I have the following, if I have P, and I also have, it's not the case that P and Q, I can affirm not Q. So notice that what we have here, we have P arrow Q, and we have P arrow Q down here. So we can use SI 34, and this is going to be, in this case, is going to be 34.1. So since I have that, I'm going to actually be able to say that I have not Q arrow P. From 1, 3, SI 34.1. And then I'm going to use 35G to get Q and not P. This is 4 SI 35G. Then I break the Q off. Why? Because Q is my goal, right there. And then since I've broken the Q off, I get to say that leads to Q. And then I get to transform this using the rule that I already knew I was going to use, namely 49.2. And since there's a conditional proof line, cross out the 2, and we're left with a 1. There are other ways that you could have tried to do this one, but they probably would have ended up a lot longer, and I'm not really about that life. And as such, we did this instead, and it worked. So for the other direction of J, though, we have to do the following. We have to say that P double arrow Q or Q is going to lead us to P arrow Q. Again, there's a few things that we could do here. You could do this with a conditional proof. It would work. You could also do it with a reductio, so I'm going to show it with a reductio. So let's start for reductio. Let's say that we have not P. So yeah, let's say that we have not P arrow Q. Assume for the sake of a reductio, this is going to get us P and not Q. Again, and statements are nice and statements are really what you want if at all possible. So we have P and we have not Q. So from that, we're going to be able to get 2SI35G. That gets us P. It gets us not Q. And elimination both sides. And then what this would end up getting us is the following. This would get us, via disjunctive syllogism, that we have P double arrow Q from 1,5 disjunctive syllogism. And now this is where, if you know SI25, you're going to be in really good luck. Why? SI25 says that if you have a double arrow and you have one of the sides, you're guaranteed to be able to get the other side. So I'm going to use SI25. You could also, for line 6, you could break it down using the definition of a biconditional. I don't want to take that time right now. So I'm just going to stipulate Q from lines 4, 6, this is SI25. But know that you might not know that one, so you'd have to do the long way. And then we're going to make the reductio explicit by saying Q and not Q from lines 5, 7, and introduction. And since we've shown that line 2 led to a contradiction, we get to say that it's not the case that we don't have P arrow Q, 2, 8, RAA, and then drop off the double negations with double negation. RAA line, discharge the 2, and we're left with a 1. So what I did here is I did both I and J, and the next one I'll do K and L.